Hi all, my name is Jeremy. I'm here to talk a little bit about analytics engineering in Databricks with dbt. I'm an associate product manager at Fishtown Analytics, the company that supports and maintains dbt, as well as being a proud member myself of the dbt open source community. You can find me there in dbt Slack, get there at community.getdbt.com at JERCO. Let's talk a little bit about the modern data stack. This is the phenomenon that has empowered so many analysts and analytics professionals in the last few years, and it's been powered by the advent of the modern data warehouse sitting at the base of it all. The ability to load raw data, unopinionated, untransformed, into the warehouse, transform it in place by writing, we'd say mostly SQL, a lingua franca of data, a language that's accessible to all analytics professionals, as well as these needs to test those transformations, version control those transformations, deploy them on a schedule, document them. Well, those are the things that dbt can help with. What Databricks helps with is expanding the definition of what's possible in the data warehouse. We'll talk about that a little bit later on. This has had implications for the data team as well. Instead of an ETL stack, where data engineers took care of all extraction, transformation, and then loading into a prepared set of data marts, we have an ELT stack. Data engineers are still responsible for extracting and loading data, but not for the opinionated transformation that needs to take place inside of the data warehouse, the data lake. That's led to the advent of this new role, the analytics engineer, someone who's thinking about how to provide on an agile basis lean, transformed data models, still implementing all the engineering best practices, version control, testing, modularity, and maintaining data documentation to make the whole thing make sense, but doing so in SQL in a place that analysts have ready access to in a language that's comprehensible to them so that they can partner all the better with members of the business. This is not a role that existed in the old ETL stack, but it's one that's become increasingly important in the ELT stack that modern data platforms such as Databricks have enabled. So what is dbt then? Well, it's at first glance just an open source Python program, a wrapper around SQL, a framework for coding that SQL. But as you get more and more into it, you realize it is the tool at the heart of this new workflow, of this new role of the work of analytics engineering. And because it's open source and because we have invested so much in the community built around it, and the community has invested in itself, it's a set of opinions and viewpoints and best practices that have agglomerated around the work of building those reusable modular data assets. Okay, so I said a little bit about what dbt is in my mind, but what it is actually is a way to define data models, to define views, tables, other materializations, or materialized data assets simply by writing SQL select statements, and to define tests and descriptions and document those data assets simply by writing a little bit of YAML. By using this magic ref function, this reference function, dbt is able to infer an entire dependency graph, a DAG of source data lineage, and actually populate that graph into an auto-generated documentation site that, again, is yours just by writing SQL and a little bit of YAML. We have here a handy animation of this magic ref function that I mentioned. We've now added stage customers as a place for selecting data from in our fact orders model. And simply by writing this Jinja function ref, dbt is able to understand and infer the lineage there. Now, I showed you ref. I showed you a little bit of what's available. That's actually a glimpse into this whole templating engine that sits underneath SQL in dbt, and that's Jinja. It's possible to use Jinja to loop over SQL that otherwise would require a lot of copy paste. Here in the image, we've got a sum case when that I'm sure we've all written over and over, forgot a comma at the end, forgot to replace one string here with another one there. That's simply not an issue. We write drier, don't repeat yourself SQL by using Jinja and leveraging it to save a lot of lines of code. In addition, we can actually get pretty fancy with the macros that are available in our own project and also ones that we can install from packages in the community. Speaking of the community, we have a lot of people who are using dbt in production today, almost 3,000 companies week by week, as well as several dozen packages, as I just mentioned, of open source transformations and macros that you can leverage in your own project. See a little bit of that in a few minutes. Lots of people who are looking at, reading, commenting on some of our recommendations and best practices for modeling techniques in 2020. Some of the techniques of the past, as well as what's possible with a more agile framework today. And almost 7,000 people, actually, I'm sorry, almost 8,000 people now who hang out in dbt Slack in the community, sharing their wisdom, their learned experience from using data tooling and different methodologies to transforming, testing, and scaling their data processes. So let's talk a little bit about how dbt interacts with Databricks in particular. Well, for a long time now, or a year and a half, which is a long time to some people, we've had an open source plugin so that dbt, which knows in general how to talk to databases, knows how to talk to Apache Spark in particular. It's called dbt Spark. You can install it from PyPy or clone it the GitHub repository, totally open source, totally out in public. We believe in writing all of our business logic in Spark SQL, and we can still get all the benefit of dynamically templating that SQL with Jinja, connecting to any Spark cluster, whether local or hosted, hitting dbt run, generating documentation. Everything I've said to you so far. That's good and exciting in the broad case, but in the very particular case of using Delta Lake and using the Databricks runtime, we still get all those core dbt features, but now we can materialize those models as delta tables, meaning that we can also use merge commands when building our models incrementally or snapshotting slowly changing dimensions. We can use post hooks or other configs that dbt makes available to us to run things like optimize the order. We also can plug dbt directly into the new SQL Analytics endpoints. So actually leverage the things that Databricks has made, the investments they've made in SQL first analytics to power our SQL first data transformation. And this is very exciting to me personally. For the very first time, we are going to be supporting that open source plugin, that extension of dbt functionality in our hosted SaaS product, dbt Cloud, which offers a full developer interactive interface, a way to compile and run SQL in real time with a Git flow, not the installation hassle of trying to manage Python environments on your local machine, as well as a configurable job scheduler with things like CI on pull requests, data documentation hosted at a stable permalink, and dbt artifacts persisted to power things like Slim CI. If you're curious to hear a little more about that, you should check out the dbt documentation. There's more to come on all of this. It's in closed beta right now. Feel free to reach out if you have any questions. My contact information at the beginning, and I'm sure again at the end. So I'm going to leave you for a couple of minutes while my good friend, me from a week ago, is going to show you what's possible in dbt Cloud, in Databricks, leveraging all of the modern practices of analytics engineering. A fictional e-commerce company that sells jaffles over the internet, a very special kind of sandwich. We've got two tables in our Jaffle Shop database here, a customers table and an orders table. Looks like the user ID in the orders table, maybe that joins to customers. Some investigation to do, some questions to ask. But let's go ahead and put on our data analyst hats and do some reporting. Let's say after some hard-fought work, we end up with a query like this one. Handle the renaming of user ID, Maybe also rename ID to order ID to make the join that much clearer later on. Give this an execute. And voila, we've got customers, their total number of orders. Well, in the process of writing this query, we've actually generated some reusable code snippets, bits that we don't want to have to rewrite over and over in our various queries here, bits we want our colleagues to be able to use and benefit from. So let's take off our data analyst hats just for a second, fix our hair. And think about how we might do this in a more reusable, modular way. That's going to be using dbt. Here, dbt cloud. I've created for myself a staged version of the orders table and the customers table. This is actually a Jinja expression referencing a source table with descriptions. I've got markdown descriptions for important columns in those tables. Now I can come in and run these models, and what that means is take the queries that otherwise I would be running just as SQL queries and actually wrap those in create view and create table statements. So it's going to be the same query result as this, but actually wrapped in views in my dbt jcohen schema, so that instead of having to write all this SQL every single time, an analyst can start here. dbt doesn't just offer a way to programmatically generate those SQL queries as database objects. It also gives us the ability to test those queries, test those objects based on assertions and assumptions that we define in YAML. Orders, one record per order. The order ID should be both unique, no duplicates, and not null. Never have an order that doesn't have an order ID. Each one of these tests at the end of the day is just SQL. It's just a select statement. Here we've got not null order ID in the fact orders table. You might be shocked to see it's just a select count star from that table where order ID is null. As long as we get back 0, as long as we find no null records, that test passes. There are all kinds of built-in tests in dbt, not null, accepted values, relationships, testing referential integrity, and unique. It's possible to test almost anything. It's also possible to write our own custom tests using Jinja, using the same templating language that we're using here to template out source references and model references. Here I'm saying that dim customers depends on these two other models. dbt will use that information in order to run those models in order, and in order to do something else quite important, which is automatically generating a documentation site that I can use while developing in dbt and also share with all of my colleagues and collaborators. Right now, dbt is running this command, dbt docs generate. What this is doing is compiling information about all the resources in my project, all the models, all the tests, the sources. Here we are. This is an automatically generated documentation site powered by a couple of JSON artifacts that dbt produced, our raw source tables, including the markdown snippet that we used, as well as the models in our project. We've also got both the source and compiled SQL here. This source includes the Jinja that we use to template our project and to infer dependencies. This is the actual compiled SQL that dbt will run against Databricks. Now, most crucially, because we've used these ref functions and these source functions, dbt is able to infer an entire lineage graph. Now, this is a pretty simple project, and you'll see DAGs with hundreds and hundreds, if not thousands, of nodes, but this is the core abstraction underlying everything that dbt does. The ability to have raw data sources, several layers of transformation, building on top of each other, each step its own modular piece, until we're able to get up to those final data assets that power our analytics. Now, you may have noticed that these tables are 100 rows and take seconds to query. That's not like many Spark workloads. That's true. For all of you, I've got something special. So let's put on our data engineering hat here and take a look at my Scala notebook. Now, this is a Kinesis stream that I'm reading from. The data in this stream is snowplow events being fired by folks visiting websites like docs.getdbt.com, as well as anonymous usage tracking from the open source technology, from people actually running invocations of dbt. And what I'm doing here is writing this stream to a delta table called snowplow event. Nothing fancy going on. I've had this running for a couple hours just to get some real data in the pipeline. Now, I'm a sufficiently talented and experienced data engineer to know that this table, as it exists right now, is not going to be very useful to my analysts. We've got a partition key, base64 encoded data field, which is actually in TSV format, stream, shard ID, sequence number, or approximate arrival timestamp. Cool. This is the Kinesis spec for streaming data into Delta. And we're looking at a little under 6 million events. Not too shabby. I would probably need to come in here and write a whole lot more code. Maybe it's SQL. It probably isn't. Maybe I want to do a whole extra roll-up layer. I don't want my analysts querying a table of 6 million events. I want them querying a table of a couple thousand sessions, maybe with some kind of stitched user identity if I have users who are anonymous at first, but then identify themselves later on after visiting my website. It's just a lot of prep I need to do on top of this data. But this isn't the hat that I'm going to wear while doing this. Instead, I'm going to wear the hat of the analytics engineer. Now, this is someone who sits in between data engineer, data analyst. A lot of the skill set and the mentality of the data engineer. At the same time, I want all the work that I'm doing to be out in the open, to be visible and accessible to analysts, and that means doing it in SQL. Here's what I've got. I've got a snowplow source. It's streaming. I can have freshness guarantees on this to the tune of the minute. Under the hood, too, this is just a SQL query. Now, this table secretly has a lot of columns in it, and I've actually used the YAML specification here to list out all those columns and the data types that I know them to have as parsed out from that big base64 encoded TSV. Instead of writing SQL like this, I've chosen a drier approach. In this case, leveraging all the power that a Jinja template can have to grab those values and then loop over those columns and output something that should look pretty familiar. I've then gone and parsed out and flattened all of my custom contexts for my snowplow data. That's a nested bit of JSON inside of one column. And grab my web page contexts, page view IDs. You'll see here that I've configured this model to be materialized incrementally. That means I'm actually going to be storing it as a delta table and running merge commands against it. Rather than rebuilding this table all the way every time, I'm just going to add those new records and update any records with overlapping IDs. Now, I've only got 3 models here, but what I've set myself up to do is install a couple of packages, including an open source package of snowplow sessionization models, bringing me all the way up from events and contexts to page views and sessions. So I'm going to run dbt deps, dbt dependencies, to install those packages, including a couple of utility packages that offer cross-database compatibility. For certain SQL functions that are just a little syntactically different in Spark, what this does is actually install those packages, clone them into this dbt modules folder, and now I get to benefit from all these models that I don't have in my project per se, but I do have installed as an open source package. Of note here is that because this model is materialized incrementally, dbt is first creating a temporary view of the model contents of the SQL, including a special filter only included during incremental runs, saying, give me only the data that is new since last I ran this table. We have handy Jinja abstractions for these things. Then merge into the Delta table on the root ID, on the thing I've configured to be the unique ID here. When matched, update. When not matched, insert. dbt is able to template out all of this materialization code simply based on the configuration that I've supplied here and which I've supplied in dbtproject.yaml. In this case, that all my models should be file format delta and use incremental strategy merge. Now, it's all well and good to run these models in a development environment. At the end of the day, we need to talk deployment. dbt Cloud can do that. It installs my packages, runs all my models, runs all the tests on those models, snapshots freshness on my data sources, and generates my documentation site. Here we've got a handy viz to say, yes, indeed, my data is fresh. Here we've got the docs. All of these models are ones that I'm pulling out of the package. I didn't have to write any of this SQL on my own, just using industry standard best practices for sessionization. I can configure this job to run other steps. I can configure it to run on a schedule or run every time I open a pull request or all sorts of other fancy things. Because I know that this is going to be running in the background and hosting documentation that my analysts can use to understand the core dimensional models that I'm building and all the code that we used to get there, including some clever Jinja macros. I feel perfectly comfortable taking off my analytics engineering hat, putting back on my data analyst hat, and creating a dashboard that looks like this, where all of these visualizations, all of these queries are being powered by my snowplow sessions table, which I got out of the package. I've got a configurable parameter here that I can switch out to use someone else's data environment, or when it's ready, the production data environment. So you see I've got almost 6 million events that I've rolled up to 65,000 page views, 10,000 sessions. I wonder how many of these dbt Cloud sessions were us just now. Well, it's already been a little more than 240 seconds, but I hope I've been able to show you a little bit of what's possible with Databricks, dbt Cloud, and the modern analytics engineering workflow. One last thing, all the code I used in this demo is available in an open source repository, Fishtown Analytics dbt Databricks demo. All the data in the first example that I was showing you is available in a public S3 bucket. Have a go at streaming through. I hope you enjoyed that demo, got a little bit of a sense of what's possible with dbt and Databricks using them together. If you like what you saw, dbt Cloud is available as a SaaS technology. Get up and running in minutes with job scheduling, the developer interface, all the fixings. If you need a little more security or customization, it's possible to deploy an enterprise edition of dbt Cloud on-premise, single tenant, or Fishtown managed. And then, of course, because dbt is open source technology, as is the Spark plugin, as is the documentation site, all of these things can be deployed by you on your own architecture and infrastructure in the same way that you would deploy any other Python program and sets of artifacts. Thank you so much for taking the time, listening to me talk a little bit about what gets me very excited, just thinking about modern data teams, modern data stacks, and all the tooling that we're building along the way. Curious to hear any feedback, as well as reach out to me if you have any questions. Again, my email, jeremy@fishtownanalytics.com, community.getdbt.com. Thanks so much.